Welcome back again. Today we're going to begin our third and final way of solving systems of equations, called solving by elimination. Now, the goal of elimination is instead of trying to get a variable by itself, you're trying to find a variable that has the same coefficient, the same number in both equations. So, what I'm looking for is in this case, notice I have x and I have a negative x. Okay, both have a coefficient of 1 or -1. Okay, if they have a different sign, that's fine too, in fact, to make it easier for you. So you're looking for the variable that has the same coefficient in both. Okay, and it helps if both are in standard form. Okay, now what you're going to do once you identify those x's, now you need to see, because we're going to add or subtract this entire equation from the other one, okay? Now, here notice it is a 1 and a -1, okay? X and negative x. When they have opposite signs mean you're going to add the equations together. So I'm going to take the complete equation and add it. So here, x plus -x, so x minus x, cancels off. It is eliminated, okay? And again, that happens because we focused on it because I had the same number in both equations. 2y plus 1y gives me a 3y. 1 plus a -7 is a -6. Okay? So notice, by eliminating those x's, now we have something that we can just solve for y. 3y equals -6. We'll divide by 3. Y equals -2. All right, now, we're still not quite done yet because, again, kind of the theme for all these systems is we need x and we need y. So I do need to go back. I need to plug y into one of my equations. So to keep it easy, I'm just going to plug it into the top equation. X plus 2 times y, but we know y is -2, equals 1. So x minus 4 equals 1. That would mean x is 5. So again, you need both pieces. And now we're able to say that our solution is 5, -2. Make sure you write it the right way. Even though we found that -2 first, when you're putting points, remember it's always x comma y. So in this case, 5, -2. And that's really the basis of this elimination method. Now, on the next one, the things I'm going to pay attention to are, notice those y's. Both have a coefficient of 2. So because both have a coefficient of 2, those are the ones we're going to focus on. And I want you to note up here, when they have the same sign, so here it's 2y and 2y, both are positive. The way to cancel that is this time we can't add it. Adding it will only amplify the problem. This time we have to subtract. So when you have the same sign, you need to be subtracting. All right? Now, do be careful when you're subtracting though, because you're subtracting everything. So here, x minus 3x is a -2x. 2y minus 2y cancels off just like we needed it to. 7 minus 9 is a -2. So make sure you remember that subtraction basically distributes throughout that entire equation. You're subtracting the whole equation, so make sure you don't forget that when you're working through this. Divide both sides by -2, you get x is 1. And again, as always, you should know that's not really the end. We still have to go back and we need to find y. So I need to take that number and plug it into one of my equations. Again, Just for easy convenience, I usually pick the top one. So x, which we know is 1, plus 2y equals 7. So that means I can subtract 1 from both sides, divide by 2, and there we have it. So I need to write my solution as a point now. Well, that point is 1, comma, 3. That is going to be the point that is true for both equations. All right. Now to finish up here, I do want to do an example of the special cases. So recall the special cases are when the variable completely drops out. Now let's take a look at how that happens. So here, notice both the x's and the y's have those common numbers, okay? The x's both have coefficient of 1, the y's both have a coefficient of 3. So because they have the same signs, I'm going to subtract the equations. X minus x, 3y minus 3y. Well, notice both of my equations dropped out this time. Or sorry, both of my variables dropped off this time. So this is what the special case looks like in terms of elimination. Then 8 minus 7 just gives you 1. So this is a false statement, right? 0 can't be 1. It doesn't work that way, okay? So remember, when the variables both disappear from your equation and you're left with something that is nonsense like this, what that means is that there's no solution. There's actually no answer that will work in both of these equations. All right, so again, just to show you what the special case looks like for elimination, is when both variables end up eliminating in the end. And then if you have a false statement left, it's no solution. If you have a true statement left, such as 2 equals 2, then it's all real numbers. Or infinitely many solutions is what I meant. All right, so once again, thank you for joining me. Make sure you come and ask if you have any questions before you get going on your practice work.